Hello, in this lesson we're looking at a normal distribution curve, but this time we're looking at it in terms of using a calculator. So when it comes to calculator functions, it's really important that we use our knowledge of the distribution curve, that our answers we get make sense of what we're looking for. So when we're looking at the normal distribution curve, let's have a quick recap of what we've looked at. The normal distribution curve involves a curve of data that represents 100% of the data. It has 6 points of data points in here, where we have a mean plus or minus deviation, which is 1 point away from the mean, a mean plus or minus 2 deviations, 2 points, and a mean plus or minus 3 deviations is the third point away. When we're looking at normal distribution, a really important thing to understand is that these percentages do not change, okay? The positions away from the mean don't change. It's only the numbers that represent the mean and deviation do change. And what we're going to be doing today is we're going to be using our graphics calculator along with our understanding of the normal distribution curve to solve functions and using correct terminology. So let's get into a question. We have our first question over here. It says, the chest measurements of 18-year-old male footballers is normally distributed with a mean of 95 centimetres and a standing deviation of 8 centimetres. So what we can write here is always a good thing to write out what your mean and deviation is, so that way it's nice and clear in the question. It's asking us to find the percentage of footballers with chest measurements between 95 and 103. So if we were going to sketch a normal distribution curve, which we'll just do up here, just so that way we can check our curve is correct. We have a mean of 95. And then if we add 8 to that, we would get 103, add another 8, 111, and another 8, 119. If we take 8 away, we get 87, 79, and 71. Now, whenever you're doing these calculations, it's good to have in the back of your mind how this works in terms of percentages. So we've been asked to find the probability between 95 is less than or equal to x, which is less than or equal to 103. Now, if we think about this in terms of the unit circle, the normal distribution curve, we're looking at 1 point away from the mean. And we know that this here represents 34% of that data. So we would expect, when we calculate this in our calculator, our answer should be about 34%. So let's now use our calculator to actually calculate these functions. On the left-hand side here, you have your Casio calculator you'll be using in class. So the first thing we want you to do here is go straight up to your menu and scroll down to the bottom, and you'll see a function called distribution. I want you to click enter on that, and then you'll get a selection panel that looks like this: binomial, normal, or Poisson. We want the normal function. So if we press enter on this, it's going to come up with, what does your tail look like? So for instance, what does it look like in terms of, is it between, is it greater than, or is it less than? In this case, we've got a notation up here where we've got a lower and an upper. So we need to change this so it looks like it's got a lower and upper. And we do this by selecting F2. And you'll notice that straight away it has the notation similar to what we have here. So we put our lower value in, which is 95. We put our upper value in, which is 103. Our deviation, which is 8. And our mean, which is 95. And once you've done this, then you can go all the way down to execute and press your answer. Now remember, we said we expect the answer to be 34%. Around that, because that's what it would look like in a normal distribution curve. So once we press enter, you'll notice that we actually get what we wanted, which is 0.3413. So 0.3413. That's what the percentage of males who have a measurements between 95 and 103, 34% of males would have that. If we have a look at the second example, and we'll raise this here now. So let's scroll up for our next example. If we look at the second example says find the probabilities. Not too high. Find the probability that the chest measurement of a randomly chosen footballer is less than. So in this case, we're looking at the mean and deviation are still the same. They haven't changed. So our probability now is less than equal to 75. Now, if you forget what does less than equal look like, the best way I think about it is less than starts with a capital L and it looks like an L. Therefore, that's less than, the opposite will be greater than. We now want to work out something that's less than 75. Now again, before you do any calculations, think in the back of your head, where would this be represented on your normal distribution curve? Well, it sits about here, I reckon. Now we know the answer, well, it's got to be less than 2. Okay, 2.5 or 2.13, but it's got to be greater than 0.15. So we're looking at an answer that's going to be around this kind of calculation. So if we come back to your calculator, let's exit this. We're now looking for a function where it's going to be less than. So less than will be this left-hand side over here. You'll notice that it matches up with your notation you have here. We want to change the x variable now to 75 because we want to find out when it's less than 75. Enter, enter, enter. And you can see that it's very, very far over this point here. So we get an answer of 6.2 times 10 to the negative 3. One thing I will say to you, if you're in an exam and you wrote this 6.2 e to the negative 3, they would mark this here wrong. And the reason why they mark it wrong is because then you're telling the marker you don't understand that this means times 10 to the negative 3. So when it comes to scientific notation, make sure you're replacing that e with a times 10 to that negative 3, which makes sense because it's down here, it's very, very small. Okay? So we've got our result and it matches up with what we have in our normal distribution all the way over here. Okay? So let's have a look at the last example and then we'll move on and finish the video. So the last example here is find the probability that the chest measurements of a randomly chosen footballer is at least 100. Now this is where it comes to the language again. At least. Think about what kind of sign would that be for at least. So at least means I will give you this plus more. Okay? So therefore we got greater than or equal to. At most would be less than or equal to. No more than, less than equal to. Alright? But at least is always going to be greater than or equal to. So again, if we look at this data here, we're looking for information that's going to be from 100 on. Okay, so if we go back into your calculator, again we're looking at what would we expect the answer to be. So we go back up to the top. We're going to say we want F3 because we want it to be at least. Okay, so it's going to be this or greater. And then we come down and we execute. And we'll see that we're looking for, oh, sorry, we didn't change the answer from to 100, did we? So let's go back up, let's change that to 100. Now actually, you know what? Let's just go back to that. Let's put 75 in there. This is a good example of a learned lesson. If we put 75 in here, have a look what's happening. It's covered 99% of that data. In the back of our head, we say, you know what, that can't exist because I only want from 100 on. And 100 on is got to be less than 50%. Okay, so I've got an answer here which is 99%, which is basically all of this data. And this is where you have to think about in your head, when it comes to normal distributions, does this kind of make sense of the answer that I'm getting? I know in the normal distribution, the mean's 95, and anything greater than that's going to be worth 50% of that kind of data. So as I move further and further left across, if I want something that's greater, it's got to be less than that 50%. Okay, so if we look at going back, and let's now change that 75 to 100, you'll see that we now have a better representation of our curve, which is 0.2659, which makes sense. We had our head that it had to be less than 50, but it had to be more than 16. So we kind of got an idea of where it should sit. And that's the power of understanding how the normal distribution curve works to make sense of your question. And then the last question here is, well, if we had 200 football players, how many of those football players would have chest measurements greater than 100? So in this case here, it'd just be 200 times 0.2659, and then you get your answer. I think that's approximately about 118. What did I have? Sorry, not 118, 53. So approximately 53 players would have chest sizes greater than 118. All right. So when we're looking at normal distribution curves and using your calculator, we've looked at the function that you need to get to the calculator. So again, to get there, you would go down to distribution and then you press enter. And if we go exit, it should bring you up this page here. Whenever we're working with normal distribution, we need to make sure that our answer makes sense of what we would expect in the curve itself. In this example here, we put 75 in there and we got 99%. However, we know from our understanding of normal distribution that can't be correct because 100's here and that's got to be less than 50%. When it comes to normal distributions and using your calculator is going to give you an answer to what you put into it. One thing you should always be aware of is whenever you work with normal distribution, you should never have negative answers. You can't get negative area, okay? Under here is another way of calculating the area, okay? So if you get a negative answer, you've done something wrong. Go back, look at your data, okay? Remember how this works so that this makes sense of what you know it should be. Always have that in the back of your head so when you're looking at an exam, you get the question, yes, that makes sense. I understand it relates to what I know, therefore it is correct. Good luck, see you in the next one.